Hello friends, today I'm going to solve LeetCode problem number 309, best time to buy and sell stock with cooldown. In this problem we are given an array prices where each element represents the price of stock on that day, and we need to find the maximum profit that we can achieve. And the restrictions given to us is that after we sell our stock we cannot buy on the next day, that is we need a cooldown of 1 day, and we cannot engage in multiple transactions simultaneously, which means that once we bought our stock we cannot buy another stock until and unless we sell our stock. So we need to buy and then sell before buying another stock. Now let's see how we could solve this problem. So just by intuition, what would you do on the first day? Well, basically you'd buy the stock, right? Because you do not have any stock so far. So what our first step is that at index 0 we try to buy our stock, right? But we also have another choice, that is we could choose to do nothing as well. So at index 0 our profit is 0, and we can either choose to buy or we can choose to do nothing. If we choose to buy, then our profit will be -1 because we are buying at the price of 1. And if we choose to do nothing, then the profit will remain the same, right? And on the next day, what we could do, like we can perform a transaction, that is a sell transaction, because once we buy we need to sell it before we can buy again, right? So we can either choose to sell or we can choose to do nothing again. So if we choose to sell it, then we sell it at a price of 2 on that day. The price is equals to 2, right? So our profit now becomes equals to 1, and if we choose to do nothing, then it becomes -1, that is, it remains the same. Again, if we sell it, then we need a cool down period of 1 day. So on the third day we just do nothing. So on a price 3 we just do nothing, and then the profit remains the same. Again, we can now choose to buy on the fourth day, and the value is equals to 0. So if we bought on that day, then our profit will remain equals to 1, and we could choose to do nothing as well. So if we do nothing, then the price will remain the same. And again, we bought on that day, now we can choose to sell on the next day, and we could choose to do nothing. So if we sell, the price is equals to 2, so we sell at price 3. So now our profit becomes equals to 2 plus 1, which is equals to 3. And if we choose to do nothing, then the profit will remain the same. So what are we doing here? If we look at the cases here, if we chose to sell, then our profit is increasing, right? That is, we are performing an addition operation on our previous profit. We are adding the value price of that index, right? Price. And if we are buying, that we are reducing the price. So on our profit we are subtracting the price, the buying price. So this is what we do. So these two formula is what we'll use. And if we are doing nothing, then our profit remains the same. So profit remains the same. Now another thing to keep in mind is that on every index we have two choices to make, right? Either to sell, either to perform a transaction, or to do nothing. And the transaction is either selling or buying, right? And only on some special cases we choose to do nothing, that is when we are selling it. So basically we can take this whole thing as one branch rather than one and two different branches. We could take this as one branch. So after each cell we just jump over two indices, so that we have the choice to either buy or to do nothing. Now this whole approach is that we are moving from top to bottom, right? We are finding the profit at each index, starting from 0th index, 0, 1, 2, 3, 4, so on, right? So this is top to bottom approach. But what I'm gonna do is I'm gonna solve this problem in bottom up approach, and it's very simple, and that can lead us to O of n time complexity. So what we are going to do is we are actually going to use a dynamic programming, that is we are going to use Memoization cache, that is save our values. Now let's first begin how am I going to solve it from the bottom up approach. So what we do is we start from the end, and the very end, my profit here is 3, right, and my profit here is equals to 1. So what I do, I take the, okay, let me just explain it with a new diagram. This is a little confusing as well. So what we do is we start from the bottom, that is index 2. Let me just tell you the concept, the idea behind that part. So I need to find the profit, right, maximum profit at this point, and I have 2 different branches from here. I have profit P1 and I have profit P2, right, and I want a maximum profit. So what will be the maximum profit? Maximum will be the maximum value between any of these two, right? Which of these two have the maximum value will be the profit at the top. So this will be the maximum between P1 and P2, right? So this is the idea that we'll be using in our bottom-up approach. So what I do is I find the profit at this index and anything beyond that. And since this is my last index, so I start from the last index and my profit so far is 0, right? And now at this index I could either choose to buy or sell, right? If I chose to buy at that index, then what would my profit be at I am at index 0. Basically my profit is 0 so far, and if I chose to buy, then my profit will be equals to -2. If I chose to sell, then my profit will be equals to 2. If I chose to do nothing, then my profit will be equals to 0, right? But buying and selling, that will depend on the transaction that we perform at this point, these 2 points. If I sell at this index, that I need to buy at this index or just do nothing. If I buy at any of these 2 indices, then I must sell or just do nothing, right? So basically I have 2 choices. To do nothing or to buy. So if to buy or sell or do nothing, right? Do nothing. So so now what I need is I also need what should I do? Should I buy or should I sell? Well, I do not know, right? Because I'm at index this last point, but I can know it if I know what I did previously. So what we need to do is we need a boolean value buy. We will use a parameter boolean value to identify what we are going to do here at this index, right? So if we are buying at this index, then our price will be reduced to -2. So that would be -2, and we take the maximum of these 2, so it would be 0, right? So we take this maximum value and then we perform our next previous transaction. That is, if this transaction was a buy, then previous transaction would either be a sale or nothing, right? Because if we sell, basically no, previous transaction would be just nothing, because if we are buying at this point, that is we cannot buy at this point because we might have sold at this point, right? So yeah, so basically that's the idea behind that. So now we found the maximum at this index. We found the maximum profit at this index, which is 0 if we were to buy, right? So which is 0. And then we do nothing here, so the profit remains the same. And then again we move on to this index, and we could either choose to buy, choose to sell, or do nothing, right? So if we choose to sell it, then what would the price be? If we sell at this point, then basically our profit is increasing, right? So +3, it would be +3, right? If we choose to do nothing, then what would the price be? The price would still be the same, the profit would still be the same. So what's the max? 3 is the maximum, right? So we take the value 3, this becomes our new profit. And now we move to the previous one. Since we sold at the previous, so this will be our buy condition, or do nothing. If we buy, then the profit would be equals to 3 minus 2, which is equals to 1. And if we do nothing, then the profit would still be equals to 3. So doing nothing gives us the max profit, right? So we do nothing, and then we move on to the previous one. And then can we buy or sell? Well, again, buying means -1, and doing nothing means 3. So what do? We do nothing. So basically this is the idea. Since I started from with an assumption that I am buying at this point, but actually we need to sell at this point, because looking at the fact, looking at this example as well, we need to sell at the end, right? But it was just an assumption, because now let's dive into coding. So I'm gonna use dynamic programming. So n equals to, so this will be our cache where we will store our values. We need the index and we need the boolean value to know if we need to buy or sell at that point of time. And if we need, we always have to check the base case before we always it's always good to check for the base cases. So if it is the end, we return 0. If not, we have the choices to buy or sell, right? So we could either choose to buy, if else we sell, right? And we also have the choice to do nothing. So we either perform a transaction or we perform no transaction. So no transaction means the profit remains the same, so I plus 1. And if we did no transaction, which means that we still need to perform this transaction, so we'll pass the same value here. Now what do we need is, since we are using DP, we also need to check if we have found the value at index I for the given transaction. If we have already calculated that value, then we just don't need to do it again and again. So I'm just gonna use DP to check if I have already computed that value. If yes, then I'm just gonna return it. Return the value. If not, then what I'm gonna do is I'm gonna calculate the value of that DP, and the value would be equals to, since it is a buy, so the price will reduce, right? Profit will reduce basically. So price plus, and the DFS function, else if it is not a buy, if it is false, this value is false, then we are actually selling it. And if we sell, we need a cooldown period, right? That is, after that day we escape 1 day. So that is what we are doing here. And when we are selling, our profit increases, so we add the selling price to our resulting profit. And then what do we do is So we take now this could also, doing nothing could also result in a value, maximum value for that index, right? So when we need to update our DP, so let DP equals to math.max maximum value of this, or the value of DP itself, which of them is maximum, and then we finally return the value of our DP, and then we call our DFS function true value because we need to buy before we make a sell. Okay, so what I'll just do here is -1 times we need a prices, not price, it's prices. Yeah, and yeah, we could, instead of doing this whole multiplication thing and then the addition thing, what we could do is we could just subtract the prices. Cool, let's submit it. Great. So the time complexity would be O of n, because for each index we are only performing the transaction once, and if we encounter the index next time, we just return the value from our cache, right? And the space complexity is O of n as well. So yeah,